Bisectors, section 6.1. Alright, our objectives: to use the perpendicular bisector to find various measures, use angle bisectors to find measures in distance, and write equations for these perpendicular bisectors. So what conjectures can you make about a point on a perpendicular bisector of a segment and a point on the bisector of an angle? Alright, let's start with some vocabulary that we're going to need for 6.1, perpendicular bisector. This is a refresher, so take some time to write down your definition, including your symbols, also the definition of equidistant. Alright, our perpendicular bisector theorem states that in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Here we have our implied statement, which is a shortened version. So take time to write all of this information in your notes. We will use this in today's activities. And then the converse is where you switch that first statement. So now we're saying that if in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of that segment. So again, take time to write down this in your notes, and also just take a moment to just really look at both of these statements and try to understand, based on the picture and our symbols, what these two theorems are all about. And then try this proof. We've got the perpendicular bisector theorem proof. So take time to maybe try to figure this proof out by yourself, and then unpause the video to check your answers. All right, please note that because you have this perpendicular bisector, it's going to create two triangles. So your plan needs to include proving the triangles congruent. And so that's what we end up doing sort of later in the proof. So we know we have a reflexive property that we can use for shared side. And then, so that's one pair of sides. And then perpendicular bisector is going to imply two separate conclusions. So let's follow this first conclusion. We can conclude that P is a midpoint of AB because segment bisector implies intersecting at midpoint. And because we have a midpoint, that helps us conclude that segment AP is congruent to segment BP. And that's because midpoints imply two congruent collinear segments. So here's a pair of sides. And then our second conclusion from our given is that angle CPA is congruent and CPB are right angles because perpendicular implies right angles. And that allows us to conclude that the angles are congruent. And that's our our third part. And that's three parts that help us conclude. So we've got a side, congruent angles, and a pair of sides. So side, angle, side allows us to prove the triangle is congruent. And then the all remaining parts are congruent, which then congruency leads to equal lengths. All right, let's use this theorem to find the length of RS. From the figure, line SQ is the perpendicular bisector of segment PR. And because of our implied statement that a point on a perpendicular bisector segment is equidistant from the endpoint of the segment, we can conclude that PS is congruent to RS. So these two segments are congruent, which means if PS is 6.8, then so is RS. All right, so let's use our theorem to figure out the length of EG. Since EH is equal to GH, which is 24, and line HF is perpendicular to EG. We also know that line HF is the perpendicular bisector of EG because equidistant from endpoint of segment implies point on perpendicular bisector of segment. So since segment bisector implies midpoint, we can conclude that the full length of EG is twice the length of FG. So we plug it in and we get 19. All right, pause the video here and you try example 1C, find the length of AD. All right, how did you do? Did you get x equals 7 and then substitute it into the expression 5x to get the length of AD, resulting in length 35? Good job. All right, let's take a look at this real-life problem, example 2. Is there enough information in the diagram to conclude that point N lies on the perpendicular bisector of line KM? So take a moment to sketch the diagram with all the appropriate markings and labels. Conclusion, it is given that KL is congruent to ML, so LN is a segment bisector of KM, but we do not know whether LN is perpendicular to KM because it's not indicated in the diagram. So there's not enough information to conclude that N lies on the perpendicular bisector of KM. All right, moving on to the angle bisector, and again, this is just a recall. We've talked about the angle bisectors before, back in Unit 1. So take a moment to refresh your memory on angle bisectors with our list of properties, implied statement, and our picture. It's just a refresher that distance from a point to a line means that the length is perpendicular. Super important, perpendicular segments. All right, so now let's take a look at the angle bisector theorem. It states that if a point is on the angle bisector of an angle, then it is equidistant from the two sides of the angle. Shorten that down to point on an angle bisector, if and only if, equidistant from sides of angle. So here we have our picture. We have ray AD is our angle bisector, and it's splitting angle BAC into two equal angles. So if ray AD bisects angle BAC, segment DB is perpendicular to ray AB. So here we have DB perpendicular to ray AB, and segment DC, so DC is perpendicular to ray AC, we see our right angle, then this length DB is equal to this length DC, and we can show by congruent marks, then DB is equal to DC. And then the converse of the angle bisector theorem states that if a point is in the interior of an angle and it is equidistant from the two sides of the angle, then it lies on the bisector of the angle. Shorten that down to equidistant from sides of angle if and only if point on angle bisector. So here we're saying that if these distances are equal, then we can conclude that ray AD is bisecting angle BAC. All right, let's take a look at example 3A. Find the measure of angle GFJ. Since segment JG is perpendicular to ray FG, and JH is perpendicular to FH, and JG is equal to JH, which is equal to 7, ray FJ bisects angle GFH by the theorem equidistant from sides of angle if and only if point on angle bisector, which is the converse of the angle bisector theorem. So we can conclude that our two angles, angles GFJ is congruent to angle JFH, and if JFH is 42 degrees, then so is the measure of angle GFJ. Okay, let's take a look at example 3B. Find the measure of segment RS. The angle bisector theorem also helps us conclude that the distance PS is equal to the distance RS. So we can set up our equation, 5x equals 6x minus 5. Solving for x, we can add 5 to both sides, giving us 5x plus 5 equals 6x. Then we subtract 5x from both sides, resulting in 5 equaling x. So by substitution, 5 in for x, we can conclude that RS is a length of 25. All right, let's take a look at example 4, another solving real life problem. A soccer goalie's position relative to the ball and goalpost forms congruent angles. And you can see the congruent marks. And then, will the goalie have to move farther to block a shot toward the right goalpost R or the left goalpost L? So will he have to move closer to the R or to the L? Start by sketching a picture of the two triangles and label all your vertices and identify the perpendicular piece, and then try to answer the question, will the goalie have to move farther to block a shot toward the right goalpost R or the left goalpost L? And the answer is that the congruent angles tell you that the goalie is on the bisector of angle LBR. And since a point on the angle bisector, if and only equidistant from sides of angle, in other words, your angle bisector theorem, then the goalie is equidistant from ray BR and ray BL. So if the goalie's right here, then he's equidistant from both sides. So the goalie must move the same distance to block either shot. All right, our final example, number 5, is writing equations for bisectors. So this is a lot of practice from algebra, just writing equations. So we want to write an equation of the perpendicular bisector of the segment with endpoints at P located at -2, 3, and the other endpoint Q located at 4, 1. Our first step is to graph segment PQ. So you're going to definitely need some graph paper for this. By definition, the perpendicular bisector of PQ is perpendicular to PQ at its midpoint. So we need to use our midpoint formula, step 2, to find M located on segment PQ. So M, after you plug in all your numbers to the midpoint formula, M is located at 1, 2. Next, we will need to find the slope of the perpendicular bisector. Well, the slope of segment PQ, after you plug it into the formula, comes out to be -1/3. And because the slopes of perpendicular lines are negative reciprocals, in other words, opposite reciprocals, then the slope of the perpendicular bisector must be 3. Notice that the slope of line PQ is negative, so the perpendicular line must be opposite. So in this case, it's positive, so these must be opposite. And then reciprocal means to take your fraction and flip it. So if this one's 1/3, then this one will be the flip of that, which would be 3/1, but you don't need to write the over 1, you just write 3. And then write an equation. So plug in all the right numbers. So the bisector of PQ has a slope of 3 and passes through 1, 2. And remember early on in our math thinking proficiency, we can plug in all our numbers that we need, and that will help us find the y-intercept. So this is one option. This is not the only option for creating a line or writing a line of an equation, but it is one way to do it. So y is 2, that passes through our point. So y is 2, so plug in 2 for y. We just figured out the slope was 3, so that goes in place of m. And then our our x value of the point that it's passing through is 1. So we plug in 1 for x, and we leave b alone because that's what we're trying to solve for. Work it all out, and so b comes out to be -1. So now you know your y-intercept is -1. So the equation of the perpendicular bisector is y equals 3 times x minus 1. And here's a visual on graph paper. If you're using graph paper to help you visualize, this is what it should look like. So we have the original segment PQ. Here's our bisector, perpendicular bisector. Midpoint M, which is located at 1, 2. All right, that's the end of this video for 6.1. Please write down all clarifying questions and